Everyone, Evgeny is back and I welcome you in another video about LangGraph Advanced. So today we continue looking into the tooling and I will show you some other ways how you can organize your multiple tools setup in your AI agents. So join me and let's take a look at that together. And again, before we dive into the details, you need to know that this video is supervised, highly supervised by angry cats. So if you're curious what are those, just check the link below. The merge is there. And let's continue. Okay, today I'm gonna show you how to use BigTool. This is a library from LangGraph itself and it's designed specifically for solving this kind of problems. I will show you different ways, another way maybe how you can try to find the proper tools using the similarity search, and this is about long-term memory in LangGraph. So we're gonna briefly touch this topic as well. And practically, we will see an example why I'm not so happy about this BigTool library. So let's get started. And again, we're going to use the same MCP servers from GitHub. So let me load them first. We have a configuration, and this is from the previous lesson. Then we can do the real thing and load the library. So we still have 73 tools here, and this is an example of the first one, how it looks like. So we're going to work with name and description mostly to recognize what tools we need in our specific use case. And now we're going to use the semantic or similarity search from long-term memory. This is a built-in capability of LangGraph. And for that, first we have to define the tool registry, and this one contains of a unique UUID, and the tool itself, practically it's a dictionary. And I'm excluding this search repository tool just because what I found when I was preparing to this video, that it's really extremely non-AI agent friendly function, because this one, if it's run without any parameters with the default ones, it just performs the searching across all the GitHub, and then you have a bunch of GitHub repository information. There's a lot of fields, and then your context limit is overexceeded almost immediately. So I have no idea what's the reason how they are supposed to use this function in the AI agent, but well, we exclude it. So what we are doing here, we define in tool registry and this list of all our tools. So there's some excluded ones, so it's 72. And this is the trick. So what we're going to do, we kind of create in a rack system, but not for documents, for tools. And for that, it's another way you can use your long-term memory in LangGraph. You can store their embeddings, and so you can perform the similarity search. Just refreshing memory, in the previous video, again, this is the idea, right? In the previous video, we used the LLM, the model call, to decide which tools would be helpful for the user request, fulfilling the user request. And this is practically another way. What we're doing here, we are creating embeddings for all the tools, and then we're gonna search across the long-term memory for these embeddings and find similar tools similar to the user request. So this is the idea. And what's here, we're creating an index in long-term memory, and again, this is what LangGraph provides us. We have these embeddings, we have the it comes from the documentation, the maximum size of each embedding, and we are indexing description field. And then what we are doing here, we are creating a namespace in our long-term memory for tools. So there we are saving the tool ID and the description. And description, I mentioned that already, we are mostly interested in tool name and tool description. So we are combining both two in a string and sending it to the long-term memory, to our store. And since we also introduced the index for embeddings, that it will be indexed as well. And this index we need in our future work. And finally, we just trying to search and show some documents in this new namespace we just created. So let me do this, and it takes time. Well, usually it takes time because, well, you have to index all the documents. All right, after 25 seconds we're here, and again, this is kind of normal situation, because in production it's a one-time job, right? You index your documents, your tools, and they are there. You're using Postgres, for example, so it's persisted. You don't have to repeat this process again. And this is what our store has at the moment. So we have items, namespace tools, and specific key. This is a tool, a unique UUID, and the value is the tool itself. So we have a description, and that one contains of the tool name and tool description. And that's practically it, right? And since we created an index, it's possible to do the similarity search there. It's kind of a rack, but not for documents, it's a rack for tools. And as an example, this is how it looks like. It's still LangGraph, it has nothing to do with tools, like you can use this technique in other use cases if you find it useful for something else. But basically how it works, you call the search method and you define the namespace, and then you provide your query and number of documents, like limit, like we are interested in 5 documents maximum. And the way it works, since we have this embeddings and index documents, from the query a vector would be calculated, and then this vector will be compared to our index data for embeddings, and similarity will be found, right? And all the documents that match the query will be in the resulting one. So for example, we have the tools for GitHub and my queries. I want to create a GitHub issue, and let's take a look what will be found. So here we have 5 documents, and practically this is create issue. So this is about creating GitHub issue, and what was found was the tool for create issue, for add issue comment, for updating, listing, and getting issues. So it looks more or less logic, right? And the first one was for creating issues. So this is the way how you can, this is another way how you can grab the needed tools for your specific request. And again, in the previous lesson, we used LLM, the model that would respond us for the tools that can be used, but instead this block you can replace with this similarity search as well. It also works, like you can give it a try on your own. It's a pretty interesting experience. All right, so we have all our parts ready for using this BigTool library, and basically BigTool library provides us a specific kind of agent. So it's here, it's LangGraph BigTool. We have a create agent function that creates for us this react, so reasoning acting agent. We define in a model, we define in tool registry, and this is our dictionary that we created previously. We can limit the number of tools for each request, like by 5, for example. And then we just compile in the graph, the agent, and we provide in our storage, our long-term memory as a storage for this agent. And this storage already contains all the tools as embeddings. So this is the key point. And this create agent, it knows about this technique, how to fetch the specific tools from the storage. So if I build it, look at that. It's a bit different, right? It's kind of partially, it's this classical React agent. So we have agent, we have tooling, it's a cycle. And then when agent thinks everything is performed, like the information can be provided, it goes to the end. But at the same time, we do have a select tools node, and this one is responsible for providing specific tools for the specific request. So agent knows when to call this one. It returns the list of tools available or useful for specific user requests, and then agent can invoke these tools multiple times until it gets the final result. So this is how this BigTool agent looks like. All right, so far so good, right? And our expectation would be that agent in select tools, it can invoke the same way the semantic search here based on user request. Provides some tools back and to the agent, and the agent has this limited number of tools, and this is the way how we solve this multiple, like 1,000 tools problem. Let's give it a try and test it. And here I have a bit simpler request, and I will explain you why. But basically I'm asking to create a new issue in my repository with some details. So I'm providing title, description, and that's it. So I have the BigTool agent, and I have my human message as a request, and let's take a look what would be the output of that. So what do we have here? We have a human message, and as expected, or as promised, we have a tool call for retrieve tools. And this time the queries the name of my repository. And available tools are search code, search organization, search users, list dependent bot alerts, and list code scanning. And finally, it seems I don't have the capacity to create issues directly in GitHub repository. So it failed. It's just blindly failed, right? It's the first stupid example. Let's give it a try. Let's try another run and see if it will be better this time. All right, this time it's better, and look at that, because the query is different. Create issue in GitHub, and so the list of tools is more accurate, like create issue, create repository, update issue, create branch, and add issue comment. And finally, there is a tool call for creating issue, and this is MCP tool. Practically, we have a title, we have a body of the description I provided, and the proper repository. And then finally, we get a response back from the tool, and the issue was created, so the agent can report it successfully. And maybe this is something why I don't like this BigTool much. Maybe you spotted the problem already. This is the query thing, and it distinguishes from what user provided, right? And it's up to the model. So the main problem here, if you look at that we have a retrieve tool. This is a tool, and the way how LLM sees it, the description of the tool, we have a description, so retrieve relevant tool based on a search query, and then we have a parameter search query, this one query, right? And we saw it here, right? And this is basically it. So it's up to the LLM to generate this query. There is no description like what kind of query, how to generate it, no examples. It's pretty standard, like very simple, just search query for something, for relevant tools based on search query. So there are no details, and that's why the LLM, what LLM can generate is really basic stuff. Like this is why I'm really not fan of this library. So for example, let it maybe make more complex. Create an issue in the LangGraph Advanced repository, my account, with the following details. And logically it's clear, right, that first of all you have a tool to recognize who is me, so get some information about myself, and then as the next iteration, probably, okay, you know that, okay, you know this guy is this one, and it should have the LangGraph Advanced, the account should have it, right? So it's pretty logical. And then you start creating issue when you know the account, when you know the repository. But let's look what LLM thinks about that. And here we are, we have a create new issue in repository. It doesn't care about whose repository is that. It's create issue, update, add issue, comment, create repository. And then it performs the create issue. But look at that, the owner is not known. It's your username, which is a bullshit, right? And then immediately we have an exception, right? And then it doesn't do any looping here. It doesn't ask for the user, for example. Like it just reports, okay, it seems an error. I mean, that's why I think, well, the library itself, well, it's far away from being a really perfect tool for separating a huge number of tools for you. But again, this is the idea, and well, sooner or later you will meet it, and you have to be aware of pluses and minuses of this approach. And practically the semantic search doesn't relate to this issue. It's a good technique, but also I wanted to show you that, so you can use this instead of making a call to LLM all the time. This is another approach. And maybe another key point here, that long-term memory can perform the semantic searches, the similarity searches, but we're gonna talk about that in the future in details. Anyway, this was a BigTool agent and BigTool library. And you saw with your own eyes that it's really not ideal at this time. Alright, this is it for the video. I hope you found something interesting and useful for you, for your work, for your agents that you're building. And you also maybe at least partially share my impression about this library, about when and which cases you can use it. And it was me, Evgeny. Thanks a lot for watching this video till the end. I really appreciate it. And well, we will see each other in the next video about LangGraph Advanced series. Thank you, take care, and bye-bye.